Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R software. You can recall that in the last couple of lectures we had a brief background about the various commands and syntax of the R software. Now in this lecture we are going to continue on the same lines, and here we are going to discuss about two aspects. One is the built-in commands, and second is that how we are going to deal the missing data. So in the R software, there is a very good facility that whenever we want to execute any process, some built-in functions have been created. And using those functions, it becomes easier for us to do the programming and to retrieve the information. So there is a long list of such built-in function in the R software, but here my objective is to expose you with such built-in function and to give you an idea that how you can use them. And in several experiments, it is possible that some data gets lost and the data is not available. So the data is not complete. And we want to conduct the statistical analysis, or we want to employ our statistical tool over that set of data. So how to employ those statistical tool when the data is missing, or I would say that some number of data is missing from the data set, and then how are we going to implement different types of statistical tools? This is another objective which we are going to study in this lecture. So let us start this lecture and try to understand that how are we going to proceed. Okay, so now what are the built-in commands? So you see, whenever you want to do any analysis, that means you have to do some mathematical operation over a set of data. Now you have two options, that because you know the mathematical format, so you can write your own program. Or the second option is that if somebody has already written such program, then you can simply call those programs and can do your analysis, right? So R has a very good facility that some of the commands have already been created and they are readily available inside the R software for various types of computation related to the mathematical function. So how to use them and how to utilize them in computing various quantities, this is what we are going to now understand. Before we go forward, let me try to give you one example to explain you some fundamental concept. Suppose I want to find out the maximum of some values. So then the command here is max, M-A-X. And now suppose my objective is that I have got four values, 4.2, 3.7, minus 2.3 and 4. And if I want to operate this max function, then how to do it? So the rule is you, as shown here, is that you write the MEX and inside the parenthesis you write all the values separated by the comma. And you can see here you will get the outcome 4.2. And you can see here I have not used here any other command like as here C. To combine the data values. Now I make some modification and I introduce the C command here to combine the data values. So all those four values are combined using the C command. And you can see here also the outcome comes out to be here 4.2, right? So in this particular example, I want to illustrate that if you are using the C command here, and if you are not using the C command here, the answer is coming out to be same. But this is not always true. In some of the function, if you don't use the C command, then usually only the first value will be considered, right? And now if you try to understand the repercussions will be when you are writing a long program and in somewhere in between you are using such command, and you want to find out the maximum among all the values, but the program will give you the outcome only as the first value. And this value will be used in further calculation, and it will be practically impossible for us to know that if there is any slip or any mistake in the values that we have obtained, right? And the same thing you can see here in the screenshot also, right? And similarly, if you try to find out the minimum, of the same values, 4 values. So you can see here I have not used the C command, and here I have used the C command on the same values, but the answer is coming out to be the same, minus 2.3 and minus 2.3. So in this case also, whether we are using the C command or not, the things are working. And but what I want to tell you that here you can see that there is a long list of such built-in commands, but most of the commands, they work only when you have got the here this combine operator C. So the question which I want to raise here is that whenever you are trying to use some such built-in function, what should you do? Should you use the C command or you should not use the C command? My personal advice is that always use the C command, right? Always use the C command. At least that will ensure that you are not making any mistake, because some commands will be using the data directly and some command will be using the data with the C commands. Right. So in order to avoid any confusion, always try to be on the safe side and always use the C command over here. So now on this R console, let me try to use here the command here, say maximum of say 1, 2, 3, 4. So this will come out to be here 4. And now if you try to use here the command here C, and C once again you say 1, 2, 3, 4. So you can see here this is again coming out to be 4. The same thing will happen with the minimum command. As I shown you, say minimum of 1, 2, 3, 4 is 1 without using C command, and when you try to use the C command here, minimum of say C 1, 2, 3, 4, it will come out to be 1. But now if you try to see here mean of say 1, 2, 3, 4, what do you expect? The arithmetic mean of 1, 2, 3, 4 is 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 divided by 4, it should be 2.5. But if you try to see here, it will come out to be only here 1. But on the other hand, if you try to use here the command here mean with C 1, 2, 3, 4, then you will see it will come out to be here 2.5. Right. So now you can imagine that if you do not give here the C command, this value 1 will be there and it will be used in the further programming, and we will never come to know if there is any problem or mistake in the value. In this case, what is happening? It is only trying to pick up the first value. If you want to change it, suppose if I say here mean of here 10, 2, 1, 2. You can see here the output will be here be actually 10, because it is considering only the first value, right? So this is a very important aspect which I wanted to highlight before I move to other built-in function which you want to use, right? So okay, I am giving you here a small list of the built-in commands which are used for different purposes. So in both the cases, I will assume that this x and y, these are my two numeric values based data vector or some scalars. So we have here a function ABS. So this function ABS is used to find out the absolute value. Oh, okay, after some time I will give you some example also so that you can understand how are we going to use it, right? Similarly, there is a function sqrt which is used for finding out the square root. Similarly, there are functions round, floor, ceiling which are used for rounding and up and down. And similarly, we have here functions sum and prod which are used to find the sum and product of the numbers inside the parenthesis which are given in the data vector x. Right. Similarly, we have log function like log, log 10, log 2. These are different logarithmic function. Similarly, we have here exp, which is an exponential function. We have different types of trigonometry function like a sine, cos, tan, a sine, a cos, a tan. So you can see here sine, cos, tan are just like the same, but cosec, sec, cot, they are represented here as a sine, a cos and a tan. So these are the command. Similarly, we have here hyperbolic function sin h, cos h, tan h, a sin h, a cos h and a 10h. Right. Similarly, there are some statistical function, or there are some other types of functions which are inbuilt. So, for example, here mean, MEAN, this is used for finding out the arithmetic mean, the average of the values inside the X data vector. Similarly, the median, MEDIAN, this is used to find out the median of the data set. SD is used for standard deviation. VAR, this is used for variance. Length, LENGTH, this is used to find out the total number of elements inside the data vector here X. Similarly, there are graphic function also like as plot. Plot is a function which creates different types of graphics for the data vectors contained in X and Y. Right. So, X can be taken as the data on X axis and Y can be taken as the data on Y axis. Similarly, if you want to convert the alphabets to uppercase alphabets, then we have the command TO upper to upper. And similarly, if you want to convert the uppercase alphabets to lowercase alphabets, then we have the command to lower. Right. So, you can see here that different types of functions are there, and this is not the complete list. There are many more such built-in functions which are helping us in various types of computation and programming. Now, I would like to illustrate here that how we are going to use such function. Suppose if I want to find out the square root of some value. Suppose if I want to find out the square root of here 4. So, you can see here, this is here, answer is 2. And these functions can be operated over scalar data as well as data vector. So, if I try to see take here a data vector like as 4, 9, 16, 25. So, the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and square root of 25 is 5. So, if you see here, this square root function goes inside each of the values and it operates here. Right. So, you can see here it's not a very difficult thing, but it is very convenient when you are trying to do your computation and inside the programming. Right. Commonly, if you try to see here, square root of 9 is 3 and square root of this data vector, which say 9, 25, 36, 49, the square root operator goes over each of the values and it gives you the value 3, 5, 6, 7. So, you can see here that using such built-in function is very easy and straightforward. Similarly, if I try to give you one more example, say here sum. Suppose I want to find out the sum of the numbers in the data vector which has 4 values 2, 3, 4, 5. So, you can see here this is trying to give us say here 2 plus 3 plus 4 plus 5. So, I simply have to write here the built-in function SUM, and inside the parenthesis I have to give the data vector, and this answer will come out to be 14. Similarly, if you want to find out the product of 2, 3, 4 and 5. So, I have to give here the data vector and I want to find out this multiplication 2 into 3 into 4 into 5, and for that I simply have to use the command here PROD, which is a short form of the product. Right. So, you can see here this multiplication comes out to be here 120. Right. So, beside those things, it is also possible that one variable can also be stored in say another variable with such command. For example, if I say here that we have understood, if I try to take here x is equal to some data vector 2, 3, 4, 5, if I try to say here y equal to x hat 2, so can we know that this square operator will be acting on each of the element, and we will get here the value 4, 9, 16, 25. Right. And now suppose if I want to find out the sum of all these values over here, that means 4 plus 9 plus 16 plus 25. So, how to do it? So, basically we are interested in finding out the sum of say sum of xi square, and xi are the values inside the data vector. So, you can see here now it becomes very simple for us. Suppose if I take the data vector to be 2, 3, 4, 5, then by x hat 2 we have seen that we get the squared values, but if I want to find out the sum, I simply have to use here the built-in function SUM sum over this x hat 2, and we will get here the values 54. So, now you can compare that if I ask you to write a program to find out the sum of squares of these values, then earlier you had learned to make a loop like sum is equal to 0, num is equal to 0, sum is equal to sum plus num, etc. Those types of concepts you had used, and then you had you had found the sum. But here if you try to see, it is very easy and straightforward to find such a sum. And this really helps us in when we are trying to do complicated calculations. Right. Similarly, if I try to give you one more example, which is a very popular quantity in statistics, suppose I want to find out here this quantity, say summation I goes from 1 to n, xi minus x bar whole square. X bar is the mean actually, and if you try to open it, this will come out to be here summation xi square plus x bar square minus twice of x bar into xi. And if you try to take this summation inside, this will become summation I goes from 1 to n xi square plus n times x bar square minus twice of x bar into summation xi. I goes from 1 to n. So this will become here summation xi square I goes from 1 to n times x bar square minus twice of x bar, and the summation xi can be replaced by say n into x bar. So this will become here summation I goes from 1 to n xi square minus n times x bar square. So this is what we want to find here. So even if you want, I can find out this first quantity also directly, and or say second quantity also directly. So if you want to find it out, you can see here that how we are trying to do it. First, let me try to write down an expression for computing summation xi square. So that we already have done by writing sum of x hat 2, right? Then after that, let me try to find out here how to compute this here n. If you try to see, n is the total number of elements in the data vector. So for that, we have a command here, length of x. And then if you want to find out here this x bar, for that we have a command here, mean. So I am writing here mean of x and then hat 2. So this will make x bar square, and then this multiplication sign over here. Right. So by writing this once single line expression, I can compute this value, and you can see here this length of x is coming out to be 4, and the value of z comes out to be here 5. Right. So I think first let me try to show you these things over the R console, and then we will do other type of calculation. So right. So if you try to see here, let me first try to show you the square root of function. So by pressing Ctrl L, I can clear the screen, and if I say here square root of here 9, so you can see here this is 3, and if I say here square root of c, now I will always use the function here c 4, 9, 16. So you can see here it will come out to be here like this, right? Similarly, if you try to take here the value here absolute value of minus 6 is say here 6, and absolute value if I try to take here the data vector minus 1 and say here minus 4 and here say here 6. So you can see here this is coming out to be like this. Now this absolute function is operated over minus 1, minus 4 and 6, and the answer here is 146. Right. Beside those things, if you want to find out here this type of thing, that suppose I want to find out the sum of squares, so you can see here I will just take the same data set so that you are convinced that what I shown you is correct. So x is now here like this. If you try to see here, x hat 2 will be like this, and if you want to find out a sum of squares, so it will be see here sum of x hat 2. Right. So you can see here this is coming out to be like x hat 2. And if you simply want to find out this value here, summation xi minus x bar whole square, so right, so I can use here the same command over here, and you will see that you get here the same answer. Right. So you can see here it's not actually difficult to find such things, right? So they are pretty straightforward and very helpful actually. Right. So now let us come back to our slides and try to take some more examples before we move forward. So similarly, if I ask you that suppose you have got here two data vectors of the same length, and if you want to find out their products, means product, and then there's sum. So what do you want here? That the elements at the respective places in the two data vectors like as 2, 6, 3, 7, 4, 8 and 5 and 9, they should be multiplied with each other and then they should be sum. So basically we want this type of expression. So you can see here when I try to do the operation x1 into x2, then I will get the something like 2 into 6, 3 into 7, 4 into 8 and 5 into 9. And when I try to make it for this here sum, then I will get the sum of this thing, which comes out to be here 110. So you can see here this is a very simple and straightforward operation. But the main thing what you have to learn here is this, that if I ask you that, okay, you have to find this thing, this type of expression, then how are you going to think that which of the function is going to be used to give you such an outcome, right? So this is pretty straightforward, right? Now I come to another aspect of data analysis. What happens that many times when we are trying to collect the data gets missed and data is not available. For example, if I say, suppose if I am conducting the survey in some locality, and suppose I have to go to the 5 houses, house number 1, 2, 3, 4 and 5. And suppose when I reach to the house number 3, then the door is locked and there is nobody who can give us the information. So in that case, we have two options. If we don't report that there is nobody in the house number 3, so for example, if I try to collect the data, then I will get the data on house number 1, house number 2, house number 3, there is nobody. And then people are there in house number 4 and 5. Now I have two options. Either I try to give the data on say 1, 2, 4 and 5. But this will indicate as if I have not considered the data in 3. But the fact is this, we have considered the data in house number 3, but the data is not available, right? Sometimes it may happen that we are conducting some crop cutting experiment and we are waiting for the crop, and suppose some night some animal come and they destroy some part of the field, and so we will not get the outcome of the yield from that area. So in that case, the data is actually missing. Missing in the sense we could have the data, but now it is not available. So in all such a situation where the data gets missed, it is represented by the concept of missing values. Different softwares have different notations and to represent the missing values. And yeah, I mean, how to do the statistical analysis with the missing data is another aspect of statistics, where we see that how we can repair the data or how we can retrieve the missing information on the basis of given set of data. But definitely I am not going to consider those things over here. My objective is only when my data is there which has got some missing values, how are we going to conduct our analysis, right? So in R, the missing values are indicated by capital N, capital A, that is NA, and this is a reserved words. So you cannot use capital N, capital A for indicating means anything else. So whenever the data comes to us, the data is collected by some other person. So whenever we get the data, our first job is to check, is there any missing value? And this is done by the command is.na, is.na, all in lowercase alphabets. So in order to explain you this, the utility of this function, let me try to create here a value whose value itself is capital N, capital A, NA. And I want to know that in this value, is there any, in this variable, is there any value which is missing? So I will write down here is.na. And inside the parenthesis x, the data vector, and the answer comes out to be here true. Capital T, capital R, capital U, capital E. Right. So true and false, they are also the reserved words. So when the answer is true, this is showing that yes, it is true, the data is missing. Okay. So this true and false, all in uppercase alphabets, they are the logical operators that are used to compare the expressions in this R software. And as I said, true and false both are reserved words. You cannot use it for any other operation. Sometimes you can also use the first letter in place of the whole word, like as you can use the capital T in place of true, TRUE, and you can use capital F in place of false. Right. And remember one thing, that true and false are always written in the uppercase and they are case sensitive. If you try to use them in lowercase, or if any of the alphabet in true and true or false is in the lowercase, this will not work. This will be something different actually. So this is what you have to keep in mind. So now let me try to give you some example to explain you that how do we work with the missing data. Suppose I get the data which has 4 values 10, 20, 30, 40. So in this case you can see that there is no missing value because no value is indicated by NA. So now, but suppose if you are getting a very huge data set, particularly in the data science you are getting thousands, millions of values, so you cannot see them with your eyes. So I will just store the data in a data vector and I will use the operation is.na and the x, which is the data vector. So you can see here the answer is like here this false, 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 false. My objective here is to explain you how to read this outcome. So if you try to see here this 10, this is corresponding to the first value here false. Similarly, the second false, this is corresponding to the second value in the data vector, which is here 20. Similarly, third value false is corresponding to the third value in the data vector, which is 30. And the fourth value, this false, is corresponding to the fourth value in the data vector, which is here false. So what false is indicating? That there is no missing value. Right. Now if I try to change this data and if I take the second value to be here NA, then you can see if you try to operate the command is.nax, then you can see here that in the first, third and fourth, this is the same as false, that there is no missing value. But on the second value, which is here, this now becomes here true and which is corresponding to NA. So that means it is trying to explain us that in this case, the second value is missing. And similarly, if I try to change this data where now second and third, both the values are missing, and if you try to operate the command is.na, then you will see here in the second and third place of the outcome there will be true, and in the first and fourth place where the data is available, the answer will be here false. So there is no data missing in the first and fourth place, and the data is missing in the second and third place. So before I try to move forward, let me try to show you these things here with the example. So let me try to create here this data here. Suppose if I say here x is equal to say c 1 2 3 4, and you can see here this is here x. So all the values are available. So if I say here is.na, you can see here everything is here is false. Now suppose if I try to add here one more value, which is here NA. So you can see here, and if I try to repeat the same command, then you can see here the last value comes out to be here true. That means the last value NA here is indicating that the value is missing. And if I try to make the fourth value also as NA, then if you try to operate this command is.na, then you can see here that on the fourth and fifth value this is true, which is corresponding to these two NAs, and 1 2 3 which are available, so their outcome here is false. So you can see here that's a pretty simple operation, but it is very important for us because whenever we get the data, then we have to first decide is there any missing value or not. And based on that, we have to choose our mathematical functions in a proper way. For example, let me try to give you here the example of, say here, arithmetic mean. That how are you going to compute the arithmetic mean when some data is missing? Suppose if I take the data set here C, 10, 20, NA and 40. And suppose I want to find out the arithmetic mean of this data x. So arithmetic mean will become here something like 10 plus 20 plus NA plus 40 divided by 4. And if you try to operate it on the R software, it will give you here answer here is NA. Right. But do you really want this thing? So you want to actually find out the mean of those values which are available in the data vector, and you want to ignore the missing values. So basically what you want here, that you want to find out the arithmetic mean of 10, 20, 40 and divided by 3. So this will become 10 plus 20 plus 40 divided by 3. But In order to obtain it, what you have to do? You have to use the same command mean, then data vector x, but now you have to use additional option here, na.rm is equal to true. What does this mean? So this na.rm means, rm means remove. So it essentially means remove na values, and you are saying true. That means yes, please remove the missing values and then try to find out the arithmetic mean of the available value. So that is why it is giving you here the answer 23.33, right? And this is here the screenshot, right? Sometime you will see that beside NA, there is another object which is here null, capital N, capital U double L. So this is also written by some of the function, and people sometimes think that NA and null, they are the same thing. But I would like to clarify here that NA and null are not the same. In fact, even NA and null both are case sensitive. So instead of here capital NA, if you write small n, it will again not be the same. And the difference between NA and null is that NA is a placeholder for something that existed but it is missing. And NU double L, null stands for something that never existed at all. For example, I took the example of the survey data where we have to collect the data from, say, house number 1, 2, 3, 4 and 5. Now there is no house number 6. So now if you try to ask me what is the data for the house number 6, then my answer will be null, because there was no house number 6. I have to collect the data only for the house number 1, 2, 3, 4 and 5. So if the data of any of this NA, this 1, 2, 3, 4, 5 actually gets missing, then I would say that will be represented by the NA. But if you ask me the data about say house number 6, then it will actually be null. So you can see here, if I try to show you this example, if I try to show you this x here is like this, which has got missing values, and if I try to find out here mean of x, you will see here this is here NA. But if I try to show you here that NA dot RM is equal to true is used here, then you will see here this will come out to be 23.33, right? So now we come to an end to this lecture, and you can see that in this lecture we have dealt very small concepts which are based on the built-in functions and missing data, and both these functions are both these concepts are actually very important for us whenever we are trying to deal with the data analysis. At many places you will have to make your own functions to compute something. So these built-in functions are really going to help you. And secondly, whenever you get the data, first step is to check whether if any data is missing or not. If the data is missing, then you have to use the option na.rm. Okay, I have taken here the example of only mean, but this concept will remain for most of the functions. So in all further lectures, whenever we are trying to take up any statistical topic, I will be dealing with the situation where we have got all the data. But you will see that in the help menu of those functions, that there is option for handling the missing data. So that will indicate if you come to know that the data is missing, then that option has to be activated. So whatever I am trying to tell you here, I am trying to take 1 or 2 examples, but these examples are going to be replicated in all the functions which we are going to use in the lectures in the future. So now I stop here, but your job starts here. Please try to take some example, try to take some built-in function, try to make their combinations. For example, you can find out the maximum values, you can find the minimum values, and you can take their combination, like as maximum value plus minimum values, and find out their absolute value. So you can think of different types of combinations which you can make and try to see whether you are able to execute them rightly and correctly on the R console. This will give you some more confidence. Similarly, I have taken the example of here mean. but I have given you here different types of built-in function, absolute, sum, product, mean, etc., etc. So why don't you create a data set where there is some missing values, and try to see how you can handle those built-in function when the data is missing. And the best way to do is that please try to look into the help menu of that function. They will give you the best information. So you try to practice it, and I will see you in the next lecture. Till then, goodbye.